Hi everyone. In the given problem statement, we are going to solve search insert position. We are given a sorted array of distinct integer and a target value. Return the index if the target is found. If not, return the index where it would have been found if were inserted in order. And the most important thing, we have to find this algorithm in big O of log n. So basically linear search won't work here. So it's an already a sorted array. So let us take the example. We have the value of 1, 3, 5, and 6. So we are going to use a concept called binary search. So out here, right, we are going to create a left side. So currently the left index would be at 0 and the right index would be the length of this entire array. So it should be length of the array minus 1, which is going to be 3. Now out here we can create a while loop while L is less than or equal to the R. So while that is true, right, it is going to work. So L, or let's say we can create another variable called mid. So mid equal to L plus R divided by 2. So you're going to double divide so that we remove the floating point. So it would be 0 plus 3 divided by 2, which would be like 1 around something. So mid would be 1 for the first case. Now you're going to check if array of the mid is less than the target. In that case, what we can do, right? So let's say for the first case, right, our current mid is 1. So 1 would be 3. Okay, so 3 is less than 5. So what we're going to do, right, we're going to shift our left pointers. Initially it's z0, right? So what we can do, we can shift it to this position, like, so we can say left equal to mid plus 1. So our current mid was 1. So after this we are going to shift it by one place, which is going to make it, because we are looking at in this position right now, right? So we are going to move it to one more position, which would be mid, or left would become 2 for that time being. Let's say in another case, if our array of mid is greater than the target, so in that case what we can do, we can basically say r equal to mid minus 1. So that would be the idea. And if array of mid equal to our target, then we can just say return the index, which would be mid. So that's the basic formula. So let us just track it down, right? So currently, right, our mid is at this position, our left is at this position, our right is at this position. So and our this would be our target value. So initially, right, our mid is smaller than the target. So what we can do, increase the mid plus 1. So now our left, right, would come into this position. Okay. So now the value would be 2 plus 3, which is 5, divided by 2, which is going to become 2. We are taking the round figure. So mid would be 2. And now in this case, right, so when mid is 2, right, so our mid value is 5. So if 5 less than 5 not true, is 5 greater than 5 not true, is 5 equal to 5, which is true, right? So in this case, this statement is going to execute and we are going to get the value. Now there could be a second condition. Let us take this example: 1, 3, 5 and 6. In this case the value is not present. So in this case, let's say if the target is not found, then return the index where it would be found if it was inserted in order. So initially, right, left would be this position, our right would be at this position, and mid for the first time, right, it would be 0 plus 3, so it would be 1, so mid would be in this position, and the target is a fictitious value which is 2, but 2 does not exist, right? So now what can happen? So basically, if the target is 2, so for the first case, right, the value, right, mid is greater than the target. So L would remain 0 because 3 is greater than 2. So we are going to decrement the R. So the value now would become, so it would be mid minus 1. So it would come to basically 0. R would also be 0 for this case. And the mid will also become 0. Okay. Now we are going to go again to this loop, and now, right, the value is 1. So 1 is smaller than 2. So what we can do, L is going to increase by mid plus 1. So the value of L would become 1, and it is going to exit and loop through. But once it is happened, right, so our L is currently not greater than or equal to R, because our R value is 0 but L has increased to 1. So our loop is going to get exited. So what we can do, right, we can basically say return L, and our L value would be 1, and current value that we are having in our L is 1. So in case there is a fictitious target which is not present the index, so we can basically have to return the leftmost value or left pointer, because that would be the index where it would be present in case it was inserted in order. So that is the idea. So this is the basic algorithm of binary search, and binary search is very, very important for your interview question. So I would suggest you, highly recommend that you learn binary search properly, because there are a few patterns of binary search and all of them are very, very important. Now let us jump to the Python solution. Hi everyone, let us create our left and right pointer. So left would be assigned to 0 and right would be the length of our nums. So while L is less than equal to R, now we can create a mid variable which is going to be left plus R double divided by 2 to remove the floating point. And now if I can say, if nums of mid is less than the target, then left would be mid plus 1 elif nums of mid greater than the target, then right pointer is going to decrease by mid minus 1, else we have found our value, so we can return mid. In case the mid does not exist in that array, right, then we just have to return the index of the left pointer. So that's a very basic solution. Now let us run it and check it out. It is saying it is out of bounds. Yeah, I made one mistake out here, because whenever you're calculating the right pointer, right, I have taken the length of nums, which is should not be the correct value. It would be length of nums minus 1, because we want the index, not the total length of the array. Now if I run it up, it should work fine. As you could see, the public test cases passed successfully. Let me submit the code, and The code submission is also successful, and it is giving a runtime efficiency of 100%. And if you look through the code, it is just giving a time complexity of big O of n, which is very, very smooth. That's all for this video. See you in the next one.